Hi guys, today's lesson is the second part of our measuring and constructing segments lesson. Today we're going to focus on midpoint, okay? How to construct midpoints, and we're also going to talk about this new vocab word here, congruent. Now, you may have heard this word in the past. Congruent means objects that have the same shape and size. So they're the same exact shape, like for example, two squares, right? But they have to also be the same size. So they're identical. So the symbol that we use for congruent is this little squiggle with the equal sign underneath. Okay, that's the symbol that we use for congruent. So whenever you see that, that's what that means. That means that two objects are the same size and same shape. Now let's talk about congruent segments. Congruent segments are segments that have equal lengths. In our last lesson, we talked about length. So if you have two equal lengths, for example, you can see right here in this picture, you have AB and you have BC, and they are both 5. Those two lengths are equal. Now, one thing that we do when we know we have equal lengths is we put like a little slash mark on the sides to indicate that those two are equal to each other. Now, if you recall from our previous lesson, this right here is our symbol for length. There is no symbol, right? I know that sounds kind of weird, but the symbol is to not use a symbol on top. You have no symbol on top for segments with length. So you know that these two are exactly 5. You know the length. You say that the length of AB, again, no symbol on top, is equal to the length of BC. So you don't use the segment symbol on top when you use the equal sign, okay? And you use the equal sign when you actually know the measurements. You actually know they're 5. So we have to use the equal sign. The difference would be if I had a similar picture, but I did not know what the measurements were. So if I just had slash marks marked on those, you would know they're equal, but you don't know what the measurements are. In that case there, that's when you use the congruent symbol. You would say segment, because remember now we don't know the lengths. We actually don't know the measurements here, right? So you use the segment symbol. Segment AB is congruent to segment BC there. Again, you use the congruent sign for segments when you know they're equal, but you don't know the measurements. Okay? Whenever you don't know the measurements, that's when you use the congruent sign. When you know the actual measurements, that's when you use the equal sign. That's when you know the measurements. Okay? So up in this particular case, we would say that AB is congruent to BC, and down here, we would say they're equal because we know the measurements. All right, let's talk about midpoint. Midpoint, when you look at this word midpoint, everybody thinks, oh, it's the middle point. Yes, that is true. It is the middle point, okay? But it's way more than that. It's a point that divides the segment into two congruent segments. So not only is it the middle point, but it also makes these two segments here equal to each other. Right? This part here is going to equal this part over here. They're equal to each other. So it's a point. Now let's talk about the word bisect. Bisect, that word bisect, stands for two, sect is to cut, so it means to cut into two. To cut into two equal pieces there. Key word being equal. It's cutting something into two equal pieces. All right, we're going to talk about a segment bisector. A segment bisector is going to be something that comes along and cuts a segment in half. It's going to cut the segment into two equal pieces. It's the bisector of a segment bisector. So what kinds of things can cut a segment, right? So here is my segment right here. Here's my segment. Here's a segment. What kinds of things can actually come along and cut through the segment? Well, if you think about it, a ray could cut through a segment, right? And it would cut through, where would it cut? It would cut right at the midpoint there. If it's cutting it right through the midpoint, if it's bisecting it, cutting it in half, it's got to go right through the midpoint. So it makes those two parts equal to each other. You could have a segment cut another segment in half, right? And it's going to have to cut right through that midpoint to cut it in half. This one you have to be careful of because oftentimes people get confused and they think, oh, well, they cut each other in half. Not necessarily. We do not know that these two parts are equal here, okay? That midpoint is the midpoint for this segment. It is not necessarily the midpoint of the other segment. It could be, but you would have to know that for sure, okay? So be careful. Segments don't always bisect each other, right? They don't always bisect each other. Very important there. You can see that. Okay, they don't always bisect each other. In the next one here, we have a line. A line could also cut through a midpoint of a segment, right, making those two parts equal. Finally, you have a plane, right? A plane could come and cut through. It's kind of like here comes the line segment and it's cutting right through there. If you take a look at that, it's cutting right through it. Another way to look at it would be to look at it like this. If you think about my pencil as being the segment, here comes the plane cutting right through, and it can cut through at any angle, but it's cutting through at that midpoint right there, okay, making this side equal to this side. Okay, so those are equal. And again, that would still right there be the midpoint. All right, so a segment bisector is a line, a segment, a ray, or a plane, any of those four things that intersects a segment at its midpoint. Now be careful with this. The midpoint itself is not a segment bisector. A segment bisector is the thing that cuts through the midpoint, like the ray or a segment or a line or a plane. The thing that actually cuts through the midpoint is your segment bisector and not the midpoint itself. Okay, let's take a look at this part down here. All right, name the congruent segments. Congruent segments. Well, if you take a look at this picture, this is pretty easy to find because all of these little parts were marked equal there, which means that all four of these segments here are equal to each other. This one, this one, this one, and this one. All four little segments are equal. Now, here's the thing. When I say equal, I have to be careful because the question says congruent. Do you know the measurements of these? No, we have no idea what the numbers are on these. But we know that they're congruent because they're marked it. So we have to write AE, segment AE is congruent to segment BE, is congruent to segment DE, is congruent to segment CE. All four of those segments are congruent. Now, if I knew the numbers, let's say that all of these little units were 3. Well, that would be different then. I could write this differently. I could say that the length of AE is equal to the length of BE, is equal to the length of DE, is equal to the length of CE. A little bit different there. This one would be if you knew the measurements, this is what you would write. Over here, you don't know the measurements, so you can't write the equal sign. You only write the equal sign if you actually know the measurements. Okay? Okay, so if you know the measurements, you would do this. If you don't know the measurements, use the congruent. Now, it did ask you for congruent anyway, but that's because there is no numbers in this picture. So I'm going to get rid of the numbers so not to confuse us, since there were none given to us. But this would be, again, if you know the measurements. All right, name the midpoint of BC. Now, the question is, what point is cutting at the middle of BC? Well, that has to be point E there. Point E right here is going to be the midpoint. The last question asked you to name the segment bisector of BC. So, what is cutting through the midpoint of BC? Well, that's easy. Line segment AD here is cutting through the midpoint of BC. So the answer to that is AD is our segment bisector. And you're naming it, right? You're naming it. So you have to use a symbol on top. You only use the no symbol on top when you actually know a measurement. Okay, so we're naming a segment bisector here. We use the symbol on top. Okay, let's look at the next part. Okay, in the next part, we're going to take a look at some midpoint problems. We're also going to use some segment addition in these as well. So let's take a look at the first problem here. Okay, it says in the figure, P is the midpoint. So if you know P is the midpoint, then you know that these two parts are equal to each other. Okay, so we could actually set them equal to each other. All right, so it says PQ is congruent to what? PQ. Well, PQ is congruent to NP. Those two segments are congruent. PQ is congruent to NP. They're congruent. All right, again, this part is congruent to this part. What is the value of X? All right, well, we're going to have to set up an algebra equation in order to solve this, okay? So previously, we were doing segment addition. And in that case, if you were doing segment addition, you would say NP plus PQ is equal to NQ, right? That's what we did in our last lesson. The problem with that is I know that NP is 3X and I know that PQ is 2X plus 4, but what is NQ? What is the whole thing? I have no idea what this whole thing is. So that's really not going to help me. I mean, even if I simplified this to 3 plus 2 is 5X plus 4, what does that do for you? Not a whole lot. Okay, not a whole lot because you have no idea what's over here. So you can't do it this way for this problem. All right, so we got to come up with a new plan. New plan. So, well, here's the thing. We know they're equal. So why don't we try setting NP equal to PQ? Why don't we try setting them equal to each other? Because we know for sure that they are equal. So let's set them equal. Subtract 2x on both sides, and you end up with x equaling 4. So the value of x is 4. And then it's asking you to find the value of NP, PQ, and NQ. So we're going to have to do a little substitution to figure that out. NP is equal to the 3x. So we have 3x here. So we're going to plug in 3 times 4, and we got 12 for that. So NP is 12. Then we're going to find PQ. PQ is 2x plus 4. So that is going to be 2 times 4 plus 4, which 2 times 4 is 8 plus 4 works out to be 12. Is it a coincidence that they both worked out to be 12? No. No, because they should be 12. They're both equal to each other. If this works out to be 12 and this works out to be 12, we're in good shape because we knew that that was the midpoint and they had to be equal. All right, and finally we have to find NQ. And NQ is made up of the entire segment. So for NQ, we have to add the NP and the PQ together. We have to add the 12 plus the 12 in order to give us the entire length of 24. Okay, let's do the next one. Now, on the next one there, we don't have a picture. If you notice, it tells you right here, draw a picture. You have to draw the picture to be able to understand these problems and what you're doing because they can get very confusing, as you'll see in the next problem. All right, so let's start with drawing a picture. Draw a picture. And the information for the picture is right here. O is the midpoint of segment FG. O is the midpoint of segment FG. Now, in this one, you'll see that they wrote the word segment in front. They could have just put the symbol on top there, right? O is the midpoint of segment FG and not had this word segment instead. So, all right, let's draw it. We have our segment FG. We have O is the midpoint. Okay. Now it says, the next part says, label the picture. Very important. Label the picture does not mean what I just did. What it means is to take this information and write it on the picture. FO, from here to here, is 3x plus 17. And then the OG, this part here, is 7x minus 15. Okay, well, what are we going to do for this problem here? What are we going to do? Well, let's take a look at it. Well, again, what you learned in the last lesson was to add them together, right? You learned to do FO plus OG is equal to FG. But once again, if we do that, we have 3x plus 17 plus 7x minus 15 equal to what? We don't know what this whole thing is. I have nothing here. So you have to be very, very careful with these problems. All right, so I can't do it this way. That won't work. So again, let's go back. We know that O is the midpoint. So these two parts are equal here. We're going to set them equal to each other. We're going to set them equal to each other. So FO is equal to OG. So 3x plus 17 is equal to 7x minus 15. All right, subtract 3x on both sides. We get 4x. And we have 17 equals 4x minus 15. Let's combine like terms, add 15 to both sides. And we end up with 32 equaling 4x. All right, now divide by 4, and your x value is equal to 8. Okay, now it asked us to write the equation, which we did. That was this part right in here. Here's your equation. And it asked us to solve for x, which we did. So we have those two pieces covered. Now, let's find FG. That's the last piece that we need to do. It's the last piece that we need to do. Okay, so let's set it up. FG is the whole thing. So let's see how I'm going to do this. I'm going to do FO plus OG is equal to that FG. So 3 times 8 plus 17 plus 7 times 8 minus 15. And all of that, whatever we get when we plug all that in, is going to equal the entire length. Okay, now I can do the segment addition postulate here because I'm trying to find out what all of this is, and I have my x value to plug in to be able to figure that out. So we need to put some of this stuff into our calculator, right? 3 times 8, 24, plus 17, plus 7 times 8, which is 56, minus 15 there. So let's plug it all in and see what we get. 24 plus 17 plus 56 minus 15 is equal to 82. So the length of FG there is equal to 82. And that was the final piece to that problem that we just solved. And we did all of the parts. Okay, we drew the picture, we labeled the picture, right? That's what we did here, drawing it and labeling it, drawing it and then labeling with given information. We wrote the equation, solved for x, and plugged it back in to find the value of FG. Okay, now let's do the next one. It says O is the midpoint of segment FG. Let's draw the picture. Again, first part is to draw the picture. There's O, segment FG. Okay, now we're going to label. Okay, FO is x plus 10. So this part from here to here is x plus 10. FG, FG, this is OG. FG is the entire thing. That part is 3x plus 10. Be very careful with this question. Up here in this one, we were just putting it on each side. This is not the case for this problem. You know O is the midpoint, so we can mark these two equal. You know that these two pieces here will be equal to each other, but I don't know what this is. I have no idea what that is right now. So how am I going to solve it? X plus 10 equals what? Well, you know it's a midpoint, right? You know a midpoint creates two equal segments on either side, two congruent segments. So if that's x plus 10, I can put x plus 10 in over here as well. Now, the thing is with this problem, like we did in the last problem, we said FO is equal to OG, right? We said that those two are equal to each other. So if we set x plus 10 equal to x plus 10, and we start to solve, subtract 10 on both sides, cancels out, x equals x. Well, that doesn't really help you, does it? We need to find an x value. X is equal to x. It's not going to work. Cross it out. Got to find a new way. The only other thing you know to do is segment addition. Let's try that. Let's set up that equation. FO plus OG is equal to FG. Okay, let's see what that says. All right, FO is x plus 10, plus OG is another x plus 10. And again, we could do that because they were equal, so we can put the same value in for both. Equals the whole thing, 3x plus 10. Okay, now let's combine like terms. X plus x is 2x. We've got 2x plus 10 and 10 is 20, equal to 3x plus 10. Subtract 2x on both sides. We end up with x there. X plus 10 on that side, 20 on this side. All right, now we're going to subtract 10 on both sides. And what do we get? We get x equaling 10. Okay, our x value is equal to 10. All right, so far we drew the picture, we labeled the picture with the given information, we wrote the equation. Here's the equation here. There's our equation, super important, right in here. And we use the segment addition postulate to do that. Now we have to find FO. FO is this piece right here, so let's plug that in. FO. FO is equal to x plus 10. So FO is equal to 10 plus 10, 20. You can always check your work as well. If you plugged x in for everything, you would see what happens there. If I plugged in the FO and I got 20 here, right? And that x plus 10 would still be 20 on this side as well. And then you actually did down here 3 times 10 plus 10. That would equal 30 plus 10, so that's 40. And then your answer should make sense, right? Because 20 plus 20 does equal 40, and these two pieces are equal because O is the midpoint. So you can always check your work there to see if it makes sense. All right, let's do one more. Now this question does not ask you to draw a picture and any of that stuff, but we have to do that. This is kind of the common sense stuff that you're going to need to do for every problem, even though they don't tell you, right? So draw your picture. U is the midpoint of BG. So that means that these two are equal. Next part we said was label. That was our next set of directions that we normally do, label. So UG is 3x plus 4. BG, the whole thing, is 10x. Okay, so this problem is very much like the last one we did up here, if you take a look there, because you didn't have this part over here. But these are equal, right? These are equal, so we can put a 3x plus 4 in on this side as well. Now remember in the last problem, if you try to set these two equal to each other, when you set two things that are the same, equal to each other to try to solve this? Because typically, right, you could do that. You could easily set those two equal to each other and solve, like we did in this one up here. But see, notice how they were different up here? They weren't the exact same expression, but down here, they are the same. So when you have two of the same, everything's going to cancel out, right? 4 minus 4, 3x is equal to 3x, divide by 3, x equals x. Again, does not help you. Does not help you. So we can't do this problem this way. It's only when the two are different, right, that you can actually set those two equal to each other like we did right here when they're look like different expressions. When they're the same expression, you can't do that. Okay, it's not going to help you. So instead, we're going to use our segment addition postulate here. BU plus UG is equal to BG, right? BU plus UG is equal to the whole thing, BG. So BU, 3x plus 4 plus UG, another 3x plus 4 equals 10x. So instead of setting them equal to each other, we added them together and set them equal to the whole thing. One of the big differences, too, is you have 3 parts here. Whenever you have 3 things, that's going to be your segment addition postulate. Up here, you only had 2. You knew it was a midpoint. You did not have the whole thing, so you could not add these together because we did not know what the whole thing was. So be very careful. In this case here, you're setting them equal, and down here, when you have 3 parts, you're using segment addition. All right, so 3x and 3x. 6x plus 8 is equal to 10x. Subtract your 6x on both sides. Divide by 4. I know I'm going through this quickly. X equals 2. If you'd like to go back and watch that again to follow the algebra, please pause your video right there so you can follow it. All right, so we get x is 2. Now this one says find BU, UG, and this should say, not BG, not BU, this should say BG. Find BG instead. Okay, a little typo there. All right, so let's plug everything in. Okay, so we have to find BU first, and that is 3 times, our x is 2, 3 times 2 plus 4, so that is 6 plus 4, that's 10, so BU works out to be 10. UG is also 3 times 2 plus 4, so that's also 10, and then BG is the whole thing, which is 10 times 2, and that works out to be 20. So when you solve this, you see that this is 10, and this worked out to be 20, which again makes sense, right? Because you can see 10 and 10 are equal, that's the midpoint, and 10 plus 10, of course, is 20. So you have all 3 of your answers there, okay? If there's any part of this video you missed, just go back and rewatch. Good luck.